Alrighty, let's see here. So, welcome back. This is now chapter 1 of using the Opentrons OT-2 Pipetting robot. Basic programming. So, I suppose first things first, I should say that this is a beginner level video. You don't need to know anything coming into this, anything about the robot. Well, you're supposed to know the stuff we talked about in the first video, chapter 0, in the introduction. Other than that, you don't need any additional knowledge, because we'll walk you through it one step at a time. And so, yeah, so let's get right into it. So, basic programming is... the goal of this video is to take the code that we have, the code base that was we've already had developed, and we just need to get the robot moving. We're going to go into more detail in the future with different videos showing how everything works. But for now, this is just a beginner level video, and so we just need to get this thing moving so we can actually start doing some liquid movement. And so first thing we need to do is we need to get to a point where we can actually start where we can actually start sending code to the robot. So if you have the Opentrons app, you open it up. Let's see here. This is what you get when you first open it. This is robots that we have. So we'll go ahead and connect to our robot. Right, it's successfully connected. And what you'll do is you'll scroll down. Don't worry about that. Scroll down a bit, and you'll see here under Advanced Settings, you see here Jupyter Notebook, and there's an Open button. So what you do is you click that, and it'll bring you straight to the Jupyter Notebook file tree. And from there, you can hit New, and you'll create a new Python script. And so that actually will bring you to where, kind of where we left off. Go over here. So this is the actual Jupyter Notebook itself. This is a file that's hosted on the robot itself. And so all the files that you use are all hosted, they're all stored on the robot itself. And so this was our initialization line up here. And we defined the plates here in the last video. And so now what we need to do is we need to actually get this thing moving. So we'll actually go over here. We're going to add this one function here, which is built in to the code that we've already developed. And so let's see, let's walk through this. So we're calling initialize OT-2. OT-2 and OT-2 simulate are pretty much identical. So if we look here, all you need to know is that the difference is that when you simulate it, it doesn't actually move the robot. It still does all the calculations and does all the loops and stuff. But it doesn't actually move the robot. Versus the actual OT-2, initialize OT-2 will actually move the robot. And so what we're doing here is inside of here, when we initialize it, there's this function here. We'll go through all this later. It looks crazy right now, but trust me, it's not that bad. We see here aspirateVolume. Okay, this function right here is all we need to get the robot moving. Okay, so we'll go over here, and if we take a look at the OT-2 right now, if I switch windows, there we go. So you'll see in slot 1, there's the 6 location labware for the 50 milliliter tubes. And you'll see on the left there we have a tube with they're all water, and it's green food coloring on the left, red food coloring on the right. And they're topped off above the volume marking that they're supposed to be at, just because it makes things easier for just making sure it works. Because these are supposed to be solvents. We'll get into more detail later. But the middle one is just straight water. It's 40 milliliters roughly of just straight water. So what we need to do is we need to combine the green and the red without mixing them between each other. And we need to take the green and put it in the middle, and take the red and put it in the middle without getting green in the red and red in the green. Okay, so we need to take oh, it's not going to show up there. And so we need to combine them in the middle one without cross-contaminating our vials or our tubes. And so here's what we need to do. Okay, so that is slot number 1, right? Solvents right here. We already defined that. Okay, we're already ready to go. I'm actually going to go ahead and switch this over to this guy, and we're going to go ahead and we're going to initialize it by hitting run right here. It'll take a while. This is fine. It happens all the time. And so this little star that we see right here is the robot. There is an indicator that code is actually running. And so in a little bit here, we'll go through what it's doing right now in the future. And so this turned from a star into a number, and so that means this cell, it's called this gray block here, it's done executing. And so now we can move on to the next one here. And so we don't actually need all of these, I don't think. So we're going to go ahead and comment those out. All we need is just this one line here, because that's the only labware we're using, right? So we'll go ahead and run it very fast, because all it is just saying, hey, I'm here, this is what I am, blah, 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 blah. Okay, easy. So now, let's get into the fun stuff. We need to take this function here and make sense of it. Okay? So let's go down here. Well, actually, let's just add another thing. Make it just a normal text box so I can type here. So we're looking at volume total. That is going to be total volume to move, right? Source plate, source location, and source volume. Those are all self-explanatory. If you watch the last video, we talked about initializing the plates. Plates. If you think of at home, you have a plate and it holds your food. Here we have a plate and it holds our liquids, right? And so what we need to do is we need to move a volume from one location to another location, right? And so so the source plate is this right here. So this thing right here. Okay, so we're gonna go take that, and that's why we name this right here, right? And so down here, we're gonna say, okay, source plate. We're just gonna paste it right in. Okay, and so let's actually start with the green on the left. So we're gonna move. So there's 40. Let me switch back here. So there's 40 milliliters in this middle vial, this middle tube here, right? So when we want to get it to 50 milliliters, so we're just going to go 10 milliliters of the green and 10 milliliters, 5 milliliters of the green, 5 milliliters of the red. And so if we switch back over, volume units for all the code that I write, that is what we're going to be talking about. All the volume units, I like to standardize the units that we use so you don't get confused. And so volume total is, we're looking at microliters. And because we want to move 5 milliliters is 5,000 microliters. So we're going to move 5,000. Right? We can actually double check this. We go here. Yep, microliters. And we'll go through this code later. Again, so now we get into the next part, source location. So if we go back over to our presentation, there's a picture here that I want to show you. And you can see here, does my mouse show up? There it is. See here how it has A1, A2, A3, and then B1, B2, B3 pretty much engraved right here next to each of these locations here. These are the location identifiers, okay? So if we want to move the green, right? The green is in the backmost one, so it's in the B row, and it's on column number 1. So if we look here, presentation, we're looking for B1 because it's this hole right here, okay? So what we'll do is when we go back to Jupyter, say, okay, source location. So now this is important. You need to add 2 quotes here because if you know a little bit of Python, the locations are stored as strings, and we'll get into this later for the intermediate stuff. But all we need to know for now is just we're going B1 and source volume. Okay, so source volume is the volume of the source file before you start doing anything. So we're actually going to go and create a new variable. We're going to call this green. We'll call this volume green, and it's in microliters. So 50 milliliters is 50,000 microliters, and we'll do the same for the red. Volume red. Now they are topped off a little bit more. It doesn't matter. We just need to make sure that it's at least the actual volume is at least this volume here, because we want to make sure that the pipette tip actually is submerged and we're not sucking up air. And we'll go through how this is accomplished, or how this is calculated again later. And so we also need to do volume water. And so 40 milliliters, that's the middle one, 40,000. Okay. And so source volume. So we're actually going to be moving, I'll add a little comment here, 5 mils green to water. Okay. So source volume is volume green. So source vial type. Okay. So if we go look over here, these are the 50 milliliter tubes. There's also 15 milliliter tubes, and there's different volumes. There's 20 milliliter vials, and there's 2 milliliter vials. And so we need to find a way where we can pretty much map the relationship between the volume inside of a tube and the height offset from the top of the tube. And so we'll go into this later, but you can find this here. If you go into custom OT-2 functions.python, you'll see here a big list of vial pipette offsets, right? And so because we're using the 50 milliliter tubes, we're going just to take this string right here, and we're just going to copy it and paste it. Don't need to know what any of those numbers mean. We're just getting this thing running. Okay, so that's our source. Okay, now our destination plate, we're on the same plate, except now we want to go to the water, which is in the middle, which is B2. We're going to make that B2. Okay, destination volume total. Right, this is where you send this here. and that's where we go. So this is our source. This is our destination. Okay. New pipette tip. Don't need to worry about that for now. Dispense rate, don't need to worry about that. Okay. So now we need to see what this thing returns. We can get back out the source volume, the new destination volume, and whatever volume is remaining. So we remember we talked about the pipettes themselves, right? If I switch over to the presentation, I have a picture here. There is a 30 microliter to 300 microliter pipette, and there is a 1 microliter to 10 microliter pipette. However, if it's let's say you have 300, you want to move 300.1 microliters. Okay, you can only do 300 microliters here, and so you're left with a 0.1, but that 0.1 microliters is too small for this. So what happens is, you can't do it, so you're left with a volume remaining. And so there's a way to check that by, if we give back, say, hey, this is a volume remaining, then we can check for that and we can count for that. But we'll get into that detail later. All we need to know is that it sends back source volume, destination volume, and volume remaining. Okay, so we're going to copy that. We're going to go here. So source volume, right? Set that to the same. Destination volume. Okay. And volume remaining. And so that's how we keep track of how the volume changes. Because if we return the new volumes after we move the liquids around, then we know what the new volumes are and we can keep track of everything, right? And we can adjust for it. And so we're just simply saying, hey, we're taking 5 milliliters from the green when we do this here, and it'll do its thing and it'll run. And it'll say, okay, so you took the original volume, which was 50,000 microliters, and you subtracted 5,000 microliters. So now your new volume for green is 45,000, right? And it'll set that there. So now this will be 45,000. And when we do it for the red, it'll be the same. However, you're adding that 5,000 to the water, so this will go from 40,000 to 45,000 to 50,000. Right? And we'll get into more detail about that later. This is just a way of tracking this. Okay? So we're moving 5 milliliters of green to water, and so now we need to do the same for the red. So we'll copy and paste. It's the same 5,000 solvents, except now instead of B1, red is in B3. And we're going to go volume red. And it's the same vial, or same tube. And then the destination is the same. Okay? And again, you don't need to worry about this or this. And we're going to go red. Red. And so this volume remaining here, we need to check if there's any volume remaining. So we're going to go print. Volume remaining. And so it returns a number. So if we want to print it out, it needs to be a string. So we just turn it. It's Python code. Don't worry about it. Microliters. Okay. And we'll do the same down here. And And we're actually going to number these so we don't get them confused. _1, and we'll name this one _2. And so, come in, _1, _2. Okay. So now, we should be all set to go. So now we need to see if, yep, so it'll take care of its own stuff. So now we should be all set to go. So we're going to come up here, and we already ran this. We're all ready to go. Okay. All we need to do is run this down here. And so with this box, with this cell selected, right, I'm going to hit run. But before I do that, I'm going to switch back over to this, and we're going to watch it and see what happens. And hopefully I know what I'm doing. So hit run in 3, 2, 1, run. Yep, so there it goes. You saw it pick up a pipette tip in the background. It picked up green. And it spits it into the middle. So what it's trying to do there is it's trying to do a wall tap, but because for some reason, like, my calibrations are wrong, the calibration files disappeared, and I can't recalibrate it for some weird reason. It is open source software. It changes all the time. It's constantly being updated, and so we'll get that fixed pretty soon here. But that's why it's not actually touching the sides, because the calibration's off. But the side touch is really nice, because if there's any drops hanging off the end of the tip that didn't get pushed out, to make sure that it doesn't get transferred, or it actually lands back in the destination file where it's supposed to be, instead of landing somewhere it's not supposed to be. And so I'll go ahead and speed this up until it's done. Okay, so this is the last transfer until it hits 5,000 microliters. And so you'll see it spit it out. I'll try and do the side touch, then it'll go up. If you watch in the back by the trash can, or the trash bin, look, it'll kick out the pipette tip, and it'll move on to the next one. Automatically knows which pipette tip number it's on. So you'll see it come back. And now it's in the red. And we do it all over again. So while it's doing that, you can see it squirted out there. So while it's doing that, we can look at what the Jupyter notebook is spitting out. Okay. So you see here, we're doing the green first, right? And you can see after it's done ejecting all of the liquid that's in here. So it sucks up the liquid from the source and spits it out into the destination. And when that's done, it'll say, okay, the new, the amount of volume, or the volume that has been transferred so far, is this, right? And it'll say, because it added that, right? And so you'll see it go all the way up from here, and you'll see here, it's 5,000 microliters, and you'll see down here in the same, volume remaining 0 microliters, which is great. See down here now for the red, it's doing the same thing. And so we switch back to the OT-2. Get a nice gross color, but it's not about the color, it's about proof of concept. getting things working. So I'll go ahead and speed this up till it's almost done. Alrighty, so this is the last liquid transfer to 5,000 microliters. You can see we get a nice dark yellow in the middle there. And you'll see in the back by the trash bin, it'll kick out pipette tip. And it'll actually recalibrate itself. Not the pipette, but like the carriage itself. Will get calibrated, and we'll show how that works in the future as well. But if we go back to the Jupyter notebook, you'll see here as well, you get the full 5,000 microliters, and again, 0 volume remaining, which is great, which is exactly what we wanted. And now, let's say, if we say volume green down here, we run it. It's exactly what it's supposed to be. If we do the same thing for red, exactly what it's supposed to be. And water, we run it. Ta-da! Everything works. And so, what's really nice is that if you run the if you run it as simulate, you can run this whole thing. It'll run it almost instantaneously. It'll take maybe a couple seconds. But you'll get the same output, so you can watch it and make sure it's doing it correctly, and you don't get any volume remaining. And so, and there's ways to deal with that if you do get volume remaining, which we'll talk about later. But yeah, we just did our first liquid transfer. The robot's moving, everything's set up, everything's working exactly as it should be, and from here on out, the only way to go is up. So I will say the learning curve is a little bit steep, but it's really, really nice having this code base that is already built and is working, so you can just jump in and go right out the bat without having to learn any Python or anything else. You're all ready to go. So with that said, looks like it's going to be the end for this chapter. I don't know what the next chapter is going to be yet. Probably going to start going into the intermediate level topics, going into detail about the functions, what's actually going on here. Maybe a couple advanced topics, like digging into the these functions down here. The base functions that are all utilized here. This is definitely an advanced topic. These are probably more intermediate. But yeah, keep your eyes peeled and let me know if you have any questions. Yeah, and we'll see you later.